Hey guys, this is Mr. Ainsworth for the last time here on this lesson. Here I'm going to show you how to do the last example here, how to find the term of a periodic investment using the periodic investment formula here. So let's go down here. We just did number 4, so the last one's number 5. Uh-oh, there's 6. I guess it's not the last one. So let's take a look at number 5 then. Okay, Ava just graduated from high school and needs to save 18,000 for nursing school. Her parents said that they cannot take out a loan to pay for her education, but she can stay at home as long as needed to save the money she needed for nursing school. Ava has a part-time job and can only make monthly deposits 750. Ooh, that's pretty good. Okay, so I know the periodic deposit there, all right, is 750 per month, so it is a periodic investment. All right, it offers 7.2%, so our 7.2%, which means it's 0.072. It's compounding monthly, so n is 12. And then it says, how long will it take to do this? How many years will it take to reach 18,000? Okay, so t equals question mark, and we need 18,000, so that's your ending balance. Okay, so that's what you do first when you read a problem. You write down what you know, and then you go for it. Okay, so here we go. Let's start off with, we need 18,000 in the long run, all right? And Ava can deposit or save 750 per month. So it's going to be 750 times 1 plus 0.072. Divide that by 12 because it's compounding monthly, and raise it to the 12t power minus 1. And then divide that by 0.072. Divide that by 12. All right. And again, we're going to be using the same procedure. So if you're looking at your notes here, just follow the same procedure as we did before. Okay? And always look at what you did before and try to understand and apply the method. Okay, so what I'm going to do is I'm going to clear the fractions. I'm going to multiply both sides by the denominator, which is 0.072 divided by 12. And of course, you got to do that to the left-hand side. Okay, now that will cancel out the fractions, make it simpler there. Also divide by 750 to simplify a little bit further, so you might as well learn to do 2 steps at once right there. So I'm multiplying these 2 fractions on the left. So let's write down what we have. So we can see it a little bit easier here. So on the left-hand side, we got 0.072 divided by 12 times 18,000 divided by 750. And if you want to simplify that, great, go for it. If you don't want to, you don't have to, okay? Because we're not using the calculator, as I said before. So just go with the flow. Simplifying is not needed. If you want to, great, go for it. On the right-hand side, I see this minus 1 on the exponential. We got to isolate the exponential, so let's cancel that out by adding 1. And then rewrite what you have. So from left to right, 0.072 divided by 12 times the second fraction, 18,000 divided by 750. And then you got that plus 1. And then all we have is the exponential term on the right-hand side because the minus 1 plus 1 cancels out. Okay. Now at this point here, we have to solve for t in the exponent. To do that, that requires log, so I need to take the log of both sides. Use square brackets here because the expression on the left-hand side is a little complicated. Just rewrite it, take the log of it. Okay, just keep it in square brackets, and then take the log of the right-hand side. Now, that's important because one of the log properties that you are learning is that you're allowed to shift the exponent, which is 12t, to the front of the log. And you'll need to do that because you got to solve for t. So shift exponent to the front. Okay, and then what do we have? So from left to right, again, left to right. So we have the log of these fractions here. So just rewrite them. That's easy. Yeah, it takes a few steps, but as long as you understand what you're doing and you practice enough, this will become easy. Okay. Now I noticed that I shifted the exponent to the front of the log there, and we're 1 step away from the answer. because what we want to do is solve for t, which is right here. It's being multiplied by the 12 and the log. So all we have to do is divide both sides by the 12 to cancel out the 12s. And then we have to divide both sides by the log to cancel out the log. Now you should be getting used to this because we do this every single time. Okay, so the procedure does not change. And so notice here that on the right hand side, those logs canceled out right there, and I got t. All right, what's t? The term? Well, it's everything you see on the left hand side. So let's write it down just to be clear. Make sure that you use parentheses correctly here. So 0.072 divided by 12 times the second fraction, 18,000 divided by 750. And then make sure you add the 1. Close off the brackets. All right. Divide that by 12 times the log of 1 plus 0.072. Divide that by 12. And that, my friends, is called the term of an investment. And it's not required here because I said leave your answers in terms of a logarithm. But on the selected response test, if you had to evaluate this thing, you would bring up Desmos here, and let's do that just for funsies. Not that it's required in this problem. And let's figure out what the term would be. So go down to your log menu here, select log, and you're going to double up on the left parentheses here, 2 left parentheses. So 0.072 divided by 12. Okay, close that off, times by the other fraction, 18,000 divided by 750. Like I said, you do not have to simplify the fractions. Make sure you add 1 here before you close it off. And then divided by 12 times the log. All right, of 1 plus 0.072. All right, divided by 12, and you'll get your term there. So the term is about 1.874 years. So a little under, almost 2 years it will take to do this, and that's not bad. I mean, think about it. You save up $18,000 in under 2 years. So it's kind of nice to be able to, figure these things out. And you guys now have the mathematics to figure it out. And then later on, I'll show you how to program this in Excel so that you can just type in a couple key things, and then boom, out pops the answer. All right. So that is how you do number 5 here. And again, this is how you find the term of a periodic investment. So make yourself proud, study and practice, and I'll see you in class.